So we're just reviewing what is open source. So Docker is a common application for web servers. It's a way to containerize applications. It runs a lot of the internet. We've also got Android, Firefox, Linux, VLC, even Git, the tool that we're going to be going over today. That's all open source. So what that means is they're open, public, often software projects. They are free as in speech, and sometimes even free as in beer, but not always free as in beer. There are some open source projects that are paid. Most commonly, Red Hat Linux is one that I can think of, and there are a few others. But all the tools that we're going to be going over today are actually free as in beer. So why would we want to make an open source project? For one, collaboration. We get help from all over the world. For two, we have remixing. So people can see our code and they might see applications for it in new and interesting ways. And furthermore, we get transparency as well. So people can check our work for errors and inconsistencies, making sure that we get things right. So in our case, we're mostly interested in collaboration and remixing, but there's also a lot of transparency that goes on to make sure that we're not making any obvious mistakes. So why might you want to get involved with open source? So we have personal reasons. So for AI on the Beach, we're a conservation project. And we have conservation projects, so we care about the ocean. You might want to learn new skills or level up the ones that you already have. Or you might be interested in professional development. Basically ways to improve your portfolio and your public presence and your skills that you want to showcase on the project. So we have partnerships also with Reef Check California, Global Fishing Watch, and Beneath the Waves. So we have visibility throughout California and actually internationally with Global Fishing Watch and Beneath the Waves. So basically, we want to go over now what is Virtual Reef. So what is the project that we're going to be looking at? So it's a tool to generate scenes like what you see here from Reef Check scientific data. So as it stands, going underwater, you don't always have great visibility, and we don't necessarily have a good idea of what the health of various fisheries and coastal reefs look like. However, we have dedicated volunteer divers from groups like Reef Check that go down and actually have these slates where they write down with a pencil what they see. So Reef Check is an open science project that tracks the health of coastal reefs. It was founded in 1996, and divers survey 50 plus species of fish, plants, and invertebrates. And they also collect data about the ocean floor for the sites that they're surveying so that they have a good idea of what the area generally looks like. So a sandy bottomed reef will be different. We expect to see different things there than we would on, say, a hard rocky reef with large boulders. Each site will be surveyed several times a year, and the surveys follow a particular protocol where they count species along a 30-meter long by 2-meter wide transect line. So, and this is what the data ends up looking like. So we currently have it structured as a very large comma-separated value file. We've uploaded this into Quilt for the Virtual Reef project. As you can see, we have hundreds of thousands of rows of data with many columns about that data. And we need to transform that into something that's a little bit more consumable. Because looking at this, it's very difficult to tell, even if I know that I'm looking at 120 Reef from the 8th of October on in September or in 2006. Looking at this, it's difficult to tell what that reef activity may have been because I've got to read through many, many lines. And then I've also got to be able to translate what it might look like to have 3 medium black perch swimming around at this spot. So to that end, we want to be able to visualize it and give some context to that scientific data. So this is in concert with other AI on the Beach projects. So a lot of these projects plug in together. One of our major ones is the Global Phishing Watch project, where we're doing ocean maps. So this is actually a representation of data of fishing vessel traffic over the course of several years. So we have our static data here on the left, and then on the right, we've actually turned that into a little GIF showing ocean vessel traffic. And ideally, what we'd like to be able to do is we'd like to be able to connect that virtual reef data over time to some of these. So what we'd like to do is we'd like to put pins on the map here and present that along with the ocean vessel traffic, so we can look at that and say, are we seeing some sort of connection between intensive vessel traffic and the health of coastal reefs? Or maybe is there a particular time when we see more reef activity? So we're kind of trying to provide as much context to this data as we possibly can. We're also making a really cool educational project where I can take a closer look at the actual reef viewer and see what it may have looked like on a particular survey at a particular time. If anybody has any questions about this, I'm happy to answer any questions about the virtual reef project or Reef Check or AI on the beach. So take just a minute here. Yes, we're not hearing a lot of questions, so we'll move on to kind of the next part. So we've kind of addressed a little bit of what is open source, and we've also talked a little bit about the virtual reef project and how it relates to Reef Check California and also the rest of the AI beach efforts. So we're going to talk a little bit now about how we can get involved and how we actually get involved with an open source project. So how to contribute? We use a tool called GitHub. So GitHub is a way for us to manage contributions. So it uses Git, which is a version control tool. There are a few main ideas with Git. So we have repositories or a repo, commits, branches, pull requests, and merging. And we're going to use Sourcetree for today's tutorial. It's a cool GUI application. Git itself is a command line tool, but that's fairly opinionated based on whether or not you're on Mac or Windows, whereas Sourcetree is pretty similar across both platforms. So it should run for everybody. So you can go ahead and download Sourcetree off of sourcetreeapp.com. And also, while you're at it, we want to make sure that that's downloaded and installed, and we want to make sure you have an account at github.com. So basically, we want to make sure that you're able to log into Git and have Sourcetree set up. So I'm going to do this so that I can show you kind of what Sourcetree looks like. So what we want to do, share my full screen here. So Sourcetree, when it's set up, it's going to look a little bit like this. So I'll give a quick tour of this while we're waiting for people to potentially download this. So on Mac, what this is going to look like is I'm going to go over, once I've got the application installed, I go over to there are preferences and accounts to log into GitHub. So that's Sourcetree, preferences, and I would pull up accounts, so this tab here. And then from there, once I've got the accounts tab selected, so Sourcetree, preferences, and then accounts, I would hit add. So once I've hit add, this little prompt will come up, and I have the choice of what host I want to be using. Sourcetree is produced by the same company that hosts Bitbucket, so they kind of push that a little bit, but our projects live on GitHub. So we can select GitHub here under host. We have the auth type. I like to use the basic auth just because I think that is the easiest way to make sure everything works. So I would put in my username. So in this case, username and my password, which comes in masked, so I'm not giving away my password or anything like that, but I've already logged in, so I don't need to finish this process. And then the protocol go from SSH to HTTPS. So once I've got that, I've got GitHub, basic, OPierce, and my password along with the HTTPS protocol, and go ahead and hit save. Now, because I did not actually create, I didn't actually put in my password and I'm already logged in as OPierce, it's going to say, hey, wait a minute, I can't save your account settings. That's correct because I've already got my account configured. So I can just go ahead and back out of that. You can see that I've got OPierce from GitHub with basic auth, HTTPS, in the default. So everything is set up for my account. And so once I've done that, and if you have any questions about how this works, go ahead and post in the chat, and we can do some debugging afterwards. So the basic flow for Git is we have local and then remote repositories. So our local repository, we have our working directory, which is basically where our project lives and where we're actually interacting with files on our computer. And then once we've made some changes, we'll run git add, which puts them into the staging area. So those are staged for commit. We would commit it to our local repo. We would push to put it up to the remote repo. We would pull to get changes from the remote, and then we could check out or merge those changes. So that's a really super fast view of how Git works. However, we're going to do a more in-depth walkthrough of each of these steps so that we have a good understanding of how Git works. So, but this is a pretty good map or architecture of what we're looking at doing with Git. So, just kind of a quick walkthrough of how to do the login with Sourcetree on Mac. So we'll send out these slides afterwards. So if anybody wants to review these things afterwards, we can take a closer look. So a repository is where our tracked project files live. So GitHub holds the remote repo, and we usually call that origin since it's the source of truth for our projects. So we will clone that project from the origin, and that makes a local copy of the repo on our computer. So I made a little sample project for you to clone here. So you can clone this at github.com/AI-on-the-beach/git-training. Now this is case sensitive. So I'll go ahead and paste this into the chat so that anybody who wants to can go ahead and try to clone this. So if you have any trouble, you should be able to get that. So now, furthermore, Sourcetree actually gives us even more help here because all we have to do is under the remote tab, you click clone from URL, and that'll pop up a little wizard here. So you want to paste in the source URL. So that's going to be our origin repo. And then you need to define the destination path. So this is where it's going to be on your computer. I had a little bit of trouble with this occasionally because it would say, oh, hey, this folder already exists. So I just typed out the name of the project I was trying to clone. So Git training in this case at the end. And it should populate that down here as well with a name. And then you can go ahead and hit clone whenever you're ready. And I think the Windows looks pretty similar. But basically, you could hit clone here, and what that'll do is that'll download the whole project and get it configured through Sourcetree. So now, the core of Git is through commits. So a commit is a saved snapshot of your project in Git. So it's like the unit of work in projects. Basically, if it's not committed, it's not really saved. Now, commits have three parts. There are changes, so the lines that are added or modified. The hash ID, which is a unique SHA-1 hash. Basically, it's a really long string of characters. So I think it's something like 32 or 64 characters long. You don't really have to worry about it because it's basically just a long word of gibberish that is supposed to be unique to your particular commit. And then you'll also have a message, which is a hopefully descriptive message from the author of that commit. So we want to make sure that when we're writing our commit messages, we're describing meaningfully what we're doing with our projects. So in order for us to stage any changes to our project, we use git add file name. So we would add the file in Sourcetree. It'll track files that are staged and unstaged and show what's being tracked by Git. And what this does is it tracks the changes to that file by adding it to the staged index. So you can see what changes are staged by looking at the diff through Sourcetree. It gives us a really cool way of seeing that. And furthermore, you can actually even get a pretty good idea of what commit changes, what commits look like on GitHub, because we can see here at the top, we've got the files that were the lines that were removed, and the bottom, which are the lines that were added. So if we take a close look, you'll see that actually these lines are super similar. And that's because Git works on what's called like a line delta. So basically, if anything on a particular line is changed, then it treats that line as though it's been removed and then added again with new values. So we can see that the only changes between the top stuff, the bottom stuff, is that win in Win32 was capitalized, but it treats it as though that entire line was changed. So that's one little piece of information about Git that is actually kind of important to understand how it works. So when we make those changes, we have to add those files, but Git is primarily designed for tracking text files. We can track other kinds of files with it, but it's not really exactly what it was designed for. So common things that I'll put into Git would include images like icons or small visual assets. But I wouldn't want to put in a lot of images because it's not great for that. GitHub has some good support for viewing image deltas. They've got some really cool ways that you can look at that. But broadly speaking, that's not the best place to put images. I actually put a PDF file in the virtual Reef project for ease of distribution. But again, PDFs are not exactly the ideal thing to be putting in there because any changes to that file aren't necessarily going to be changes like text changes. They might have larger data file changes. So any large data file, like a video or a database, that's not really great for Git just because it's not going to behave like a text file where changing a single line is isolated to that individual line. Because if we change around databases, we can see pretty large scale changes from even a relatively small change. So the next concept in Git that we want to go over is Git branches. So a branch is a timeline of commits. So I'll pop ahead. We've got this idea here where we have branches. So we have the mainline branch here, master. We have your work and someone else's work. Each color of dots here, each dot represents a commit, and each color represents a separate branch. So we'll pop back to our definition here. So we start with the main or default branch checked out, and branches are how we collaborate with Git. So the main branch is the source of truth for the project, like we said. And typically, adding commits directly to the main branch is not a good idea. It's a bad thing because we want to make sure that anything that we put on there we can check against and review separately. So to avoid adding commits directly onto the main branch, what we'll do is we'll check out a new branch. And each time we make a commit, it'll go onto the head of the branch that we're on. So in order for us to merge branches, that's how we would get our changes from like a feature branch back onto the main branch. So it combines the timeline of our commits, and we would merge branches to main so we can share our work. We can also merge, we merge from a source branch into a target branch, and that makes it so that the target branch has no conflicting differences from the source branch. So basically, if we look at our visual example again, we've got master here, and we can see that at this point, this is where someone would check out a new branch, and we can see that these commits are happening on a separate timeline from these commits. And we can see that somebody else checked out a new branch here. So while we're working on in blue, orange is working on something else over here. And when we're done here, we would merge our work back into the timeline. So this is where that would happen. And we can see that that gets put in here with this commit. And then this person can then merge their work back in, and that creates a merge commit there. So note that one of the things that I mentioned was that we had, when we merge our work back in, we need to make sure that there are no conflicting changes. So merging works great if we added a new file or if our changes fit in with the target branch. But what if they don't? Say I want to change Win32 to be capitalized Win32, and my coworker wants to change something to Mac, for example. We'd get a merge conflict. So basically, if there are two changes that are kind of happening more or less at the same time, we need to resolve those before we can merge those changes. So we resolve conflicts by doing a local merge of the main branch into our branch, and that'll create that merge conflict, and it'll say, hey, wait a minute, both of these changes happened, and it'll put in some conflict markers in the files, and we as the human being then have to go in and make the change on the code to get it back to what we actually want in our master branch or in our main branch. So basically, a quick review of Git commands. So to safely make changes, we would check out a Git branch. To track changes to a file, we would add that file. And we also have to add the changes in a file. To save our work, we would do a Git commit. To get all the new commits from GitHub, we would do a Git fetch. To update our branch with the remote, we would do Git pull. And this does like a Git merge in the background of the branch that we're on. And then to publish our commits to GitHub, we would do Git push. So I mentioned how we have the local repo on our machine, and we also have the remote repo at origin. So basically, we're coming back to our diagram here. So basically, in our working directory, we would make changes, and then we would add those changes to get them into the staged changes for a commit. So once we've got those changes added, we can commit to save those changes as a commit to our local repository. Once we've got it committed, we would push up to our remote repo, and that will publish those changes so that our coworkers on the project can see exactly what it is that we've done. And we can also pull to get the changes that other people have. So that'll merge that back down into our local repo. And then we can check out other branches, and we can merge other branches locally. So that's kind of a quick overview of Git. So how do we merge our work into an open source project? So we would issue a pull request for that. So basically, if we pop back to our diagram here, once we've committed our changes to our local repo and pushed them up to our remote, great, we've got those changes, everything's done. We've even pulled down whatever other changes and merged them into our branch so that we know for sure everything is going to work out just fine. Well, in order to get those into the main branch of the project, we need to issue a pull request so that the maintainers of that project can review those changes and merge them in. So basically, when I make a pull request, I am saying, hey, take a look at these commits. So you can see the changes, the commit messages, even the hashes and the timestamps are all visible to the maintainer when you issue that pull request. And you're able to even see the commits to public projects on your GitHub profile. So if you ever are talking to a recruiter or something like that, and they ask about your GitHub, if you have commits to a public repository, that is one concrete way to say, yeah, I've done this work. This is me. So people can see that, and that forms part of your portfolio. So how do we create a pull request on GitHub? So we've got to commit our work first. We push our work up to GitHub, and then we go to the pull requests section of the repository. We would click the new pull request button, change the compare branch to the branch that we want to merge in, and then we would click create new pull request. Now, typically you'll also want to add in some comments about what you've done with your pull requests so that the maintainers can see, oh, this solves this problem, because we can see your commit messages, but adding a note to your pull request, giving a quick summary of it, helps us understand what it is that you're contributing and how we can what to expect from your pull request. So now we've gone over how to contribute. Now this is how we know what to contribute. So for any given project, you need to have a way of tracking the issues. For AI on the Beach, we use GitHub issues to track the features that we need work on or any bugs that we might have in our code. So issues on GitHub are how we track the work that needs to be done. Project managers and maintainers can use issues to report bugs and describe features. And issues also track who is working on something so that we avoid redundant work. Because again, if it's an open source project, we on the core team have a pretty good idea of what we're working on. But if we have someone relatively new joining, it's difficult to say who's going to be working on what. Obviously, good communication is best. But you can comment on an issue on GitHub, and we can assign that to you so that we can basically know who we expect to be working on something so that we're not going to have merge conflicts or redundant work. So this is a quick screenshot of what the issues section of a project will look like. So for Virtual Reef, you can see that we've got 8 issues here, and you can see that we've got a list of them. They're numbered. It shows when they were released, who published that issue, and then the title associated with that issue. So if we even go in and take a closer look at an individual issue, you can see that I created this issue 23 days ago. There isn't any conversation on it. And this is just a section of it, but we can see that I've got a description of the issue, which I could probably improve on, to be honest. We probably need to give a little bit more detail on this one, because I'm just saying we need an API contract describing how we'll structure our data. Cool, what does that look like? And if it's unclear, absolutely leave a comment, ask questions, because getting some of those details out is actually part of the work of a project. So also you can see we have assignees. So if you click on that little thing there, we can assign that out. We can have labels, and we can also assign issues to projects. So that's kind of a quick review of Git and GitHub and how we work with all of those things. So kind of a quick overview of what we're looking for Virtual Reef. We need help on a lot of different fronts. So a lot of the time, GitHub positions itself as being kind of for programmers, and programming is definitely something that would be helpful for this project. But there's more ways to contribute to open source projects than just writing code. So more than writing code, we need design, DevOps, security, data science. We need some coding, so Python and JavaScript scripting. And we could also use some project management help, to be completely honest, because right now this is basically a three-man show. And this is a volunteer passion project for us. So we're obviously collaborating with some pretty cool organizations to help us get this data. And we'd like to make sure that we're doing the best that we possibly can with it. So part of that is we need designers to help us generate visual assets. So we have a bunch of design assets for some species that are being surveyed in the Reef Check manual. But we also need help building the UX for viewing sites, surveys, and transects. So help us see how this will all fit in together, and also create the visual experience of the virtual reef. We need somebody with some DevOps background, so can help us build an efficient, scalable AWS environment. That would be really cool. We need to make sure that our site is reliable and available. And also, we want to make sure we have a good backup system to protect our data so that we're not going to end up with significant data loss or downtimes. Security, you guys are going to be pretty important for us too, because we need to be sure that we're not going to be burning up our AWS credits without thinking. We want to protect our systems from DDoSes. We want to protect our data intake API against evil input, even potentially provide us with some monitoring for suspicious activity, making sure that we're not basically getting hit by distributed attacks or something along those lines. And on a more simple level, we even just need help getting our SSL certificate set up. That's relatively simple, but it's an important skill. And furthermore, there are risks and threats out there that we could use more background on as well. So security is a pretty broad field, and we could use a little bit somebody who's thinking about that kind of thing on our project. We also need data scientists. So you can analyze trends in reef activity on each site, compare regional trends, or create a prediction engine for the reef health. Also, as I said before, this is kind of under the umbrella of AI on the beach, where we're considering global trends as well. So we are able to find more data streams, such as the vessel traffic and other details. So being able to look at that at a holistic level and figure out what kind of data science projects might be viable for that would also be super helpful. We also need people to help us with Python and JavaScript scripting. We're using Django for the project, and we want to get a RESTful API so that it's relatively easy for us to build the application. We need to build the reef generation system, so we need a way to build those images. And we also want to integrate with Kepler.js to present survey sites so that we have a good way to present our work. And we also need to write tests to make sure our code handles edge cases. So we want to make sure that just in case we get some weird data from Reef Check or someone else, that we're not going to crash our server or have some weird results from our application. And we also need project management help. So that means planning the work for features. We need writing more detailed issues on GitHub describing the work. We could even develop a product roadmap, getting an understanding of what comes next. Because we've got a pretty good idea right now of what we want for version 1, but how do we get past version 1? How do we get to something cooler? And furthermore, create promotional and educational materials for this. Because this is a public science project, our impact is also going to be linked to how much people are viewing our materials. So we have collaborations with a bunch of other environmental organizations, but how can we do outreach to groups like aquariums and even classrooms to show what might be happening in our oceans? So thank you everyone for sitting through the presentation. I appreciate your time. I'd also like to give special thanks to Purple Mathur and Eric Simmons for their help getting the project put together. Thanks to Long Beach Women in Tech for helping host and promote this one. And I've got their information here in the presentation if you'd like to connect with any of them. And also, if you'd like to stay in touch with me, I'm Owen at AIonthebeach.com. I'm also in LinkedIn, so go ahead and find me there. And you can find AI on the Beach at AIonthebeach.com or on LinkedIn. I'd also like to send a special thanks to Cyber DEI for helping promote this event. You guys were really great for all of that. That's kind of our quick rundown for the presentation. So if anybody has any questions or if you'd like to take a look at another part of the presentation, feel free to, the floor is open. So I see we've got some questions here in chat or comments. So yes, Adriana, the Sourcetree app is the right place to get that. So.
What experience levels are you looking for? Can anyone just starting out do this?
So the Virtual Reef project I've got set up as a learning project. So I'm intending for this to be something where we have anybody of any experience level coming on in. So as long as we're able to properly review people's work using pull requests, then we should be able to use this as a way that people can connect with the AI on the Beach projects and get an understanding of what we're doing with data science. So, yeah. Time limit. Because we're a volunteer organization and we're partnered with a bunch of other nonprofits, we don't really have a time limit on our work. So that gives us a little bit of flexibility on when we're able to work on this. So again, this is a nights and weekends passion project for us. So we're happy to work on this. And Nancy, yes, I can get you a copy of the presentation slides. So I think I can probably just share that link here. So see a couple people asking about when they can where they can find this information afterwards. So let me just grab slides here. So there we go. So that's a link to our presentation. So Kima, typically team members communicate with each other through Discord. So we have a Discord channel that I can provide the link to. Feel free to reach out to me and I can send that along. And I'll also post invites to our Discord in the chat. Actually, so see, Serena's asking, do we have a selection process for volunteers? Thanks, Prapel. So as far as a selection process for volunteers, again, for the Virtual Reef project, this is an open project. So if you want to join our Discord and ask questions, feel free to ask. That's my Discord going off like crazy. So I think that we had a few people join here. So that's pretty cool. Welcome, everyone. But yeah, so we don't really have a selection process for volunteers because as an open project, we want people to join and learn from the project. So ask questions, and we usually have hack nights on this on Thursday nights, and we also put in a little bit of time on the weekends as well. But as you're able to contribute, feel free to ask questions, and we'll all work through it together. So that's kind of how it works.
You asked the time commitment.
And time commitment. Thank you. Yeah. So for the time commitment, in order to get a meaningful amount of work done, the time will vary from person to person. And again, because it's an open source project, we we don't like to put expectations on volunteers. For our board members, we personally make a time commitment to you as volunteers that if you ask questions or post comments on issues or pull requests, we make sure that we review those in a timely fashion. So that is something where we want to make sure that we're respecting your time for showing interest in our project. But for a volunteer, feel free to just drop in, ask questions, and if you're able to contribute through either design or infrastructure or any of those other things, we can work with you around your schedule. So just let us know. So yeah, that's kind of the structure for AI on the beach.
Oh, you should tell them about the Thursday hack nights, because that could also be helpful.
Oh yeah. So Thursday nights we'll typically get together. So usually we get on between 5 and 6 p.m. Pacific time, and then we go till probably 9 or 10 Pacific time. And we just hack on our Discord general channel. So that's a great time to come on, ask questions about the project, or even propose new ideas. So it's a pretty casual hangout where we have people just kind of chill. So that's usually myself, Eric, and Prayfold just hanging out and working on code or whatever it is that we need for the project that day. So it's a pretty cool environment. We often share in our Discord channel a lot of stories about ocean conservation or AI or data science. So it's a cool learning environment. And if anybody has any Python questions, we have a lot of people who have quite a bit of experience with Python who can help answer Python questions as well. So it's a fun environment. So yeah.
Does anyone have questions about the project or where we're going with it? Oh yeah, Eric, thanks for putting that up too.
Yeah, so Eric was adding that we have other chats open for topics like COVID-19, which has some rather grim data science projects. And also, as an environmental group, we're also a socially conscious group, and we want to make sure that we're tracking things like Black Lives Matter, because we want to make sure that we're engaged with our communities. So we have some data science projects that we're tracking there related to police violence and brutality. So just generally a place for people who are interested in data and data science and machine learning, artificial intelligence to all come together and check out cool stuff. So yeah.
Yeah, and also beyond the police brutality, there's also a lot of environmental policies that impact people of color or indigenous populations, especially as climate rises. Like, farming gets much harder. There's a larger refugee crisis when like countries in South America are seeing like entire businesses collapse. Like there's in Maine, for instance, the lobster industry collapsed recently, or is starting to collapse in the Northeast. So there's a lot of like overlapping intersectional challenges that we ended up adding that Black Lives Matter channel once it started to become more obvious that our policies can either promote some of these like oppressive policies, or they can actually tear them down. And so we'd like to go with the latter and actually reconstruct some of the economies and policies to promote benefits for everyone.
Yeah, so we've got a lot of interesting stuff going on over there. So if ocean conservation is interesting or any of these other things, we're happy to discuss Python, data science, and all that kind of stuff, or just talk about general technology. So, but yeah, that's pretty much what we had for today. So if anybody wants to reach out, we've got our information out there. I see Hima's asking, is anyone already working on the security part of the project? So that's something where a lot of that's going to be doing Django configuration and also some of our AWS configurations as well. So we'll want some advising on that. So we don't have anyone who's actively engaged at that point, but we'd be happy to hear what people have to say about it, because while we've got some pretty good resources in terms of our AWS credits, we want to make sure that we're as efficient as we can be about them. So we want to make sure that all works out well. So anyways, thanks everyone for your time. And I think that we'll cut our recording here. So